Sir, please proceed. Sir, Director sir.
Yeah.
Dr. Adi, please proceed.
Yeah, thank you, Dr. Naresh. Yes, Kumar. Yes.
Yeah.
So, very good evening to one and all present in one of this important event of the induction program. As part of the induction program, every year we conduct a motivational talk series. The idea is to motivate you, to encourage you towards various aspects of life. Remember that a river cuts through a rock not because of its power, but because of its persistence. In the journey of life, we need, along with energy, power, wisdom, a guiding light, which is an essential component to be a successful and achieve happiness. Motivation speech and talk series is meant to motivate you, to guide you towards achieving excellence and happiness in life. Today, we are assembled on this virtual platform to experience a motivational talk by some of the most prominent speakers today we have in our country. Before going to him, I would like to request our Honorable Director, Professor Shivaji Bandyopadhyay, for his welcome address in this August event.
Good evening, Shri Professor Ajoy Kumar Ray, my colleagues, and the BTech first year students. I was expecting a higher number, but I believe that very soon the number will increase, and maybe because of connectivity issues or some other things, the number is not up to that expectation. At the same time, I have got the feedback that the induction program that we started from 23rd of November, so that has gained momentum. And when your classes are going to start from the 2nd of December, because till 1st December, there will be the online reporting for the next batch of students. So we expect that there will be the full batch will be joining the induction program platform from next week onwards. So the team which have reported to the institute in the first batch, so they are fortunate enough to be part of these motivational talk, inspirational talk series by Padma Professor Ajoy Kumar Ray. And the question that automatically might come, that is, say, in the induction programs, on one side there are activities which there will be mentors from the institute side, faculties, senior students, and those activities have already started. And at the same time, we have also invited our own people, Padma Professor Ajoy Kumar Ray, who also is a regular mentor, regular motivator, not only for the students, but also for the faculties as well. And why we need a motivating talk? It is because, say, all of us, all of you students, you have the potential to rise to the occasions, and you can really do the magic. Because when you see after these admission process is over, so the students sometimes they are happy, sometimes they think that okay, there might be some other higher places where we could have gone. But ultimately, one thing that all of us need to believe is that because of your hard work, perseverance, and disciplined nature, you have arrived at an institute which is the best place for you and where you can really do the magic. And this magic you can see and you have seen, that is when on the orientation program, the seniors or the pass out students were sharing their experiences, what they received from NIT Silchar. And in order to start that process, what we I think what we feel it necessary for all of us to listen to Padma Shri Professor Ajoy Kumar Ray, who is an institution by itself. So when Dr. Arif will be going through his profile, you'll be knowing that is what are the say the milestones that he has touched. But above all, say when we formed the Undergraduate Research Council in the NIT Silchar, so Professor Rai was our chief mentor. The idea of the Undergraduate Research Council was to inculcate the research activity among the students. And as I have said on the very orientation day also, that we need undergraduate research, not only that every undergraduate student will publish paper or will have patents, but because in a technological institution, in a technological world, the technology is changing so rapidly. So by the time, say, you finish your 4 years of your study, whatever you have learned, whatever techniques, whatever devices, equipments, algorithms, processes, systems, so they might have changed in the meantime. So you need to keep abreast of what is going on and how to innovate yourself, how to give a jerk in your brain so that in the world when you face after your 4 years of your study, whether it is a job or it is a higher study, it is a research activity, you find that you have been trained up in the right direction in the right institute. And for that, we are the only institute in the country which have a undergraduate research council where we systematically promote undergraduate research. We provide financial support to the undergraduate research teams, and moreover, in all these undergraduate research teams, we have the postgraduate students also. We have the senior PhD students, because students actually learn from their peers, from their failures, from their success also at the same time, and from the challenges that they have faced. And though sometimes I feel that that is this period of uncertainty and the tension that through which you have gone through. So obviously your parents and your near and dear ones with you. But let us for once, let us feel that, say, we are fortunate that we have been through this, say, the tensed situation, through this crisis period, because that crisis period has learned us a lot of lessons. Had it been a very cakewalk kind of thing, maybe those lessons would never have been learned. And through these talks also, say today we have Padma Shri Professor Ajoy Kumar Ray. Say we have basically 4 talks and three industry talks basically. So total 7 invited talks in this series. So the details obviously will be shared to your email IDs. And now I request Dr. Arif to share the profile of Professor Ray to the students.
Thank you very much, sir. We are extremely happy to have a director in the form of Professor Shivaji Bandyopadhyay, who not only guides us, but always stand behind us, supported us. Us means faculty, staff, and students. And I hope by the time our students also have experienced the calmness and the blessings of our honorable director, sir. Thank you, sir. I would now like to introduce to you Professor Padma Shri Professor Ajoy Kumar Ray, sir. Padma Shri Professor Ajoy Kumar Ray is an academic expert with an experience of more than 40 years. Professor Ajay Kumar Ray is currently working as Director, JIS Institute of Advanced Studies and Research after his retirement as Professor of Electronics and Communication Engineering at IIT Kharagpur. He was on leave from IIT Kharagpur to join Bengal Engineering and Science University, Shirpur, as Vice Chancellor from 2009. He was also the first Director of Indian Institute of Engineering, Science and Technology, IIEST, Shirpur, from 2014 till 2018. He was also the Director of NIT Agartala, NIT Sikkim, IIIT Kalyani. Prior to these assignments, he was Professor of Electronics and Electrical Communication Engineering and Head School of Medical Science and Engineering at IIT Kharagpur. Professor Ray had his bachelor's degree from Bengal Engineering College, Shirpur, followed by MTech and PhD from Electronics and Electrical Communication Engineering Department of IIT Kharagpur. He joined IIT Kharagpur as a faculty in 1980. Professor Ray has successfully completed 20 research projects and several consultancy projects sponsored by several agencies like Defense Research and Development Organization, DRDO, Department of Atomic Energy, Department of Science and Technology, INDAL, and so on. He was the principal investigator of research projects sponsored by Intel Corporation during 1997 to 2004. During the course of this research project, he was the co-inventor of 6 US patents jointly with Intel Corporation. Professor Ray was the chief investigator of Texas Instruments sponsored research project being conducted at the School of Medical Science and Technology at IIT Kharagpur. As a part of this project, he, along with other team members, have filed 5 US patents jointly with Texas Instruments. Professor Ray was associated with the University of Southampton as Senior Research Fellow during 1989 to 90 and led the research group on image and video processing at Avicer Incorporation USA during 2004 to 2005. He has published more than 160 research papers in international journals and conferences and has authored 5 books which was published by international publishing houses such as John Wiley, McGraw-Hill, Patience, Printers Hall of India, Taylor and Francis publication, including one in Chinese. In addition, under his leadership, his group in School of Medical Science and Technology has initiated a number of research projects on molecular imaging and image processing, medical instrumentation, early detection of oral, breast and cervical cancers, coronary artery disease detection, epidemiological studies, and bioinformatics, all of which are of national importance presently. Professor Ray is the fellow and member of many professional bodies and is involved with large number of universities in their academic bodies. He has been serving a number of national committees on higher technical education. Professor Ajay Kumar Ray has been conferred with the Padma Shri in 2017 for his outstanding contribution in science and engineering category. A wonderful leader, a profound researcher, and above all, a wonderful human being who is holding the heart of a gold. Professor Ajay Kumar Ray has inspired many generations of scholars and students. I am extremely happy and privileged to request Professor Ajay Kumar Ray to start his session.
Thank you very much, Arif. A very good evening to all the participants, the fresh men and women who have joined NIT Silchar, the distinguished faculty members from NIT Silchar, and my very good and dear friend, the director of NIT Silchar, Professor Shivaji Bandyopadhyay. At the outset, let me convey my very best wishes to all those who have joined this great institution. And I can assure you, my dear students, that you have taken the right decision. I have been observing NIT Silchar for quite some time, and then I can assure you that this is undoubtedly, possibly at this moment, not only one of the best, but the best NIT in India. It will take a little bit more time, as you may be knowing that this year, with the hard work of the faculty members and students, under the very, very able leadership of the director, Professor Shivaji Bandyopadhyay, the institute had achieved so many milestones. And this is possibly for the first time in its entire history that NIT Silchar, it has found its place in the Times, international higher education, international ranking, and a number of other ranking, platforms also. They have adjudged this great institute, NIT Silchar, as one of the best in India. And I can tell you that amongst all the NITs, with many of which I am also involved directly or indirectly, I can tell you that this is undoubtedly, from all perspectives, from all aspects, one of the best. And those of you who have joined this institution, you have taken the right decision. So, my dear students, since the director who has been truly working, almost 17 to 18 hours a day, the faculty members, they are really putting a lot of their toil, and the students who have been actively participating not only in academics but also in kind of undergraduate research, as Professor Bandyopadhyay mentioned, and also in extracurricular activities. So you will find this place to be one of the wonderful places where you can learn a lot, and that's what makes a person an all-round person. My dear students, I thought that let me tell you today a story. Now it's a story of science and technology, but then every story, it must have a beginning, isn't it? Now, I was thinking that where to start, because this whole journey, it should start somewhere. And then some time back, I thought that the best time to start with will be the year 1665, long time back. Do you know, why it was a very important year? It was an important year to all of us because, number one, it was in 1665, the whole of England, it witnessed a massive, devastation by another, devastating plague virus. Like today, we are all affected by COVID-19, and 1665 also saw almost, lot of people, some lakhs of people in England had died out of plague. University of Cambridge was closed down for more than a year. So in 1665, Sir Isaac Newton, he was a student in Cambridge, in the University of Cambridge. And since the university was closed down, like today all the universities, engineering institutions are closed down because of COVID. So in 1665 also it happened, the same thing happened. So Newton, he had to come back to his home place, which is slightly in the northern part of England. And Cambridge is near to London. I had visited Cambridge a number of times, a wonderful place. But then Newton, after coming back, what he could achieve during the next 2 years, 65, 66, it's unbelievable. And I'm sure that all of you can only just, read that. And then you can, even if you can do something nearer to that, that's a great achievement. When Newton, for the first time, joined Cambridge, what was the status of the education, the science? Because much before that, the whole world had witnessed 2, 3 important things. And one of that was starting with Copernicus and then with Galileo's, telescope, and then the Kepler's laws of planetary motion. So from Copernicus, Galileo, Kepler, this really had given a big boost to the understanding of nature, to the understanding of the universe. For the first time, human being could see how it really looks like. So that the whole worldly view is not centered on the earth, but it is centered on the sun. Heliocentric concept was started. So that was on the one way. But then when Newton had joined Cambridge, they were teaching Aristotle's philosophy on natural science. It's interesting to note that Aristotle, whatever he had talked about, so Newton, he had gone through another great scientist, and you all should know his name. And maybe that since many of these names will not be taught regularly in your engineering courses, but remember that these are the people who had given the foundation of what we do today. And his name was Descartes. Descartes was a great French, scientist. And for the first time, he had given a physical basis to the entire universe. Newton had gone through Descartes' writings, and 1665 means, there were hardly not many such books in the conventional sense. But when he got that long leave out of plague and he came back home, he started thinking. Now, these 2 years, what he could achieve is fantastic. And one of them was he started with optics, because optics always was considered to be the basis of the mechanical system. He had, written quite extensively on optics, on mechanics, the laws of mechanics. The most important thing is he could conceive, and he had given the foundation to calculus, as all of you and many of you may be knowing. And although the book was published much later in 1887, I suppose, but then the whole basis of the classical physics, as we talk about, it was given a solid foundation by Newton, sitting at home, thinking about the planetary motion, the laws of inverse laws of, attraction or repulsion. Imagine the whole of mechanics today, on which much of our engineering is based, was developed. The fundamentals of that was developed by Newton way back in 1665, 66, 67, etc. And he became the Lucasian professor at a very early age. He had just completed his undergraduate, and within 2 years, he became and he was given this post of Lucasian professor. That was a real, a challenging thing. So Newton's contributions you all know, because whatever you have studied during your 11 and 12, much of it it involved, Newtonian laws of mechanics. Corpuscular theory was an important theory. You had studied possibly in your class 12 the Huygens wave theory, which took, hundreds of years after that, the next theory came. And then it was again one such very important year in the entire history of science came in 1905, when Einstein for the first time had talked about and had published 4 phenomenal research papers which had completely topsy-turvied the entire understanding of physics and natural physics in the whole world. So what Newton could achieve during that 65, 66, that's a wonder year for Newton. For Einstein, it was 1905. So from 1665 to 1905, there had been number of brilliant scientists. I will tell that in 1665, it was not only Newton. You have heard about Robert Hooke's. Hooke's law you have studied in your school. You may be knowing, or you may not be knowing, that it was Hooke's who for the first time had developed a microscope. And today we are talking about how to see the COVID virus. So for the first time, a plant fungus that was not on a tree, he could identify the pores, he could identify through the microscope that he had developed way back in 1665. So this year is important even from that point of view. So that was when we talk about, how to image or how to image the biological systems. Again, Hooke's was one of the pioneers. So there had been a lot of other people, and I should not forget to tell you that another gentleman, his name was Robert Boyle. You have studied also, because I thought that I must start with something which you have already studied in your 11th and 12th. Boyle's law you have heard of. Boyle had given the chemical basis of the physical systems. So these were the people who had given a solid foundation to the world of science. And based on this foundation, for hundreds of years, lots and lots of developments had come. But then interestingly, all these developments, if you just see in the history of science and technology, you will find that the developments, they come not very frequently. But then, to challenge the Newtonian's laws of mechanics, the next kind of mechanics for micro or for nano objects, which is known as quantum mechanics, a completely new theory, it took so much of time. That means it was only in the 20th century that the quantum theory, it had replaced, not completely, but then it was a much more advanced theory compared to the classical physics or classical theory which was founded by Newton. So you may think that, okay, quantum theories, etc., what is the utility of it in engineering? Remember that much of tomorrow's engineering, especially in the area of computer science and engineering, it will be guided by quantum computers. Because when you will be, when you will be quite, in your profession, you will find that within decades, a large number of such quantum computers will be available. So I will come to those things slightly later on. But then, what I wanted to tell you at this point of time, that for every invention or innovation, there was something before that. And the most important thing is to understand that how we came to this point. For example, it's not that Newton studied everything, but then people say that, okay, Newton found an apple falling from the tree, and then he, discovered the laws of gravitation. That is a very, that's true, but then not very much true in the sense that Newton had in his mind the complete concepts which had been given by other physicists before him. He knew about, Kepler's work. He knew about the Galileo's work. He knew about the Copernicus's work. He had studied very extensively Descartes and other French physicists, their work. So there was a lot of other things in front of him. He had been thinking. So remember, my dear students, yes, it is very important to think about something which gives a very novel kind of idea, which challenges the existing idea, which challenges the existing, concept, and much more important in today's world, which challenges the existing technology to find out something new. So Newton was one who could do it those days. Now let's see that, okay, it was not only in the case of science. This had happened in almost many other branches of the human endeavor of learning, in science, in art, in literature, in poetry, in music. You talk about anything, there had been tremendous developments by some or by someone or by some small group of people which had really given the world very, very new ideas. So my first thing is, the new students, I will be very happy if your teachers will be very happy, your director will be very happy when you come out of the college and then you really do something great. Since time is very short, because in 1 year, in 1 hour's time, starting with 1665 to today it is 2020, is very difficult to really do justice to so many, very, very important inventions and innovations. So many things have happened. But then I think since time is less, to inspire you more, let me tell you a little bit about the Indian perspective. Because after all, we were not because, in 17th century, it was still the Mughal period in India. And as you know that, okay, in 1757, the Battle of Plassey, it had occurred. And then we came under the rule of first the East India Company. And then we were in 1857 onwards, we were directly under the British government, the British monarchy. And that continued up to 1947. So in India, things were very difficult, especially after the British would come. We had a large number of industries, not very advanced, because in those days, but then you will be very much surprised to know that within a decade of the development of the steam engine, you know about the steam engine which was started in England by James Watt and George Stephenson. And then that which is the basis of all mechanical engineering stuff today, and which was the basis of the first industrial revolution that we see today. So steam engine, within almost a decade of development of steam engine in England, it came to Calcutta. And very interesting. And then in Calcutta, not exactly in Calcutta, but near Calcutta, there's a place called Srirampur, where you might have studied in your history book that William Carey. So for the first time, it was a big place where William Carey, he had first started the printing machine in India. So printing was started in India by William Carey. But many people, they do not know that in William Carey, he had a very huge garden. So for the first time, a prototype model of steam engine was brought there in William Carey's garden. Imagine it was India in 19th century. So there was almost nothing. A lot of people, they came to see a steam engine, how it looks like. Ordinary people, common people, artisans. So one such artisan, he had come all the way from North 24 Parganas district of Bengal to this Srirampur, which is in Hooghly district. And then he came on foot and walking for more than 4 to 5 hours. And then he came and he saw very meticulously how the steam engine looks like. Okay. And then again he went back in the afternoon. Again he came the next day. Imagine, my dear students, that this kind of observation and this kind of observation with absolute focus. So this gentleman, he came for the second day and saw the same machine. And then from morning to evening, till the whole things were closed and they were all, driven out by the security. So he saw every part of steam engine. He went back, and then it was he, a person whose name some Konmokara, these days I forget the names. So it was for the first time that this gentleman, he had developed a steam engine which was in a sense even better than the steam engine which was developed in England based on James Watt and George Stephenson's development. Not only that, he had developed it on his own using the kind of things which are available just strewn here and there. And then that steam engine, after 2 years, I think around 1823, then William Carey, he had given a call for flower competition. Lot of people, they came to participate in that competition. People, they have developed different types of, exotic flowers, very big flowers with different colors and with different, fragrances. So they came and then there was an exhibition of flower. And there this gentleman again came. He didn't come with a flower, but then he came with his own steam engine. And he showed how that steam engine can be useful for irrigation purpose, for flowering the plants, for taking water out of them. So that was really amazing. Nobody could think about that. Hundreds of people, they have brought lots of flowers, but then to grow those flowers, those days, it was really very tiresome thing, and especially in the places where water is very scarce. This gentleman, he came with his steam engine to show how it can be useful for using the steam engine, how the water can be pumped out. And the British government, somehow they were very happy, and the viceroy who came to see this flower show, he declared that a scholarship of 25 rupees will be given to this Karmakar to do his mode development and research per month, 25 rupees. So 25 rupees those days was a huge amount. So it will be almost, I mean, equivalent to what you are paying as your tuition fee to NITs today. So that was a huge amount, and then he started developing. Now, this gentleman, he was not an engineer. He didn't have any degree. He was just a very common person. How could he develop it? He could develop it just by his observation, just by his understanding of the principles based on which the machine works. And the more important thing is how could replace some of the parts or the components by the components which are available in India. So that was a great thing. And like this gentleman, there were plenty of people. You may not be knowing that before the in 1857, that was the year the Sepoy Mutiny took place. And Sepoy Mutiny also started from Barakpur. It's a place near Calcutta. And Sepoy Mutiny, it also started parallelly in 3-4 other places. In Uttar Pradesh, and Bahadur Shah Zafar, he was the last Mughal empire. He had given the leadership to this entire, the Sepoy Mutiny. Now, when the mutiny started among the Indian sepoys who were working under the British rule, then it was not, the British people, they found it very difficult. You know how it was spreading from one place to another? By telegram. So, this is again another development. Telegram, those days, in 1850s, the telegram, when the first telegram was, this using a kind of a code which was known as Morse code. It was developed in somewhere around early 50s. And within a few years in India, again some 3-4 native Indians, they had developed a telegram, a telegraph machine where they had used logs, very big logs of the big trees. And then they used their, innovative way of joining those through the telegraphic wires. And then the codes were also decided, and through those codes, they could transmit the messages from one place to another. It was very innovative. Who had developed it here? Indians. And the British people, during 1857, before that, the British had, connected almost large parts of the country, especially the different state headquarters, with telegraph. Now, when the Sepoy Mutiny started, through telegram from one place to another, the British people, they were sending the messages. But the Indian, all these sepoys, they started breaking and burning those telegraph, those poles. So again, that's an interesting thing that without the telegram, the British in 1857 could not have won so easily in the Sepoy Mutiny. Maybe that would have been their first defeat and major defeat. Maybe that there could have been a situation where they had to leave India forever. But anyway, so there are lots of such things. Who had developed them? Indians. Now, they were not engineers, because those days there was no engineering college. The first engineering college in India started in 1847, and that was not a college. That was simply a small workshop at Roorkee. And they were just giving training to the apprentices who will work on the Ganges, project, because the Ganges was one of the major things. Ganges, the river Ganges, it starts with Himalayas, and imagine that it crosses through the entire North India, and then comes via Bihar to Bengal, and one part it goes now to this side, to Bangladesh and all. So it's very interesting that they wanted that Ganga Action Plan and Ganga Project. It was started by the British in those days, and to really train up the engineers or the supervisors who could work there, they started a small workshop. And that's how the Roorkee Engineering College was started. And the Roorkee Engineering College, later on, yes, somebody had mentioned that it is now IIT Roorkee. So, and then came, three more engineering colleges were started around 1856. One was the institute with which I was involved, that was in Shibpur. Professor Banerjee, your director, he had mentioned about that institute. That is a very old institute, 1856, and College of Engineering, Pune, and then Gindi Engineering College in the south. One in south, one in east, one in west, and north Roorkee. So four such engineering institutes, but other than Shibpur first started giving the degrees, that too much later in 1880s. So before that, they were just giving some diplomas and all. So it's very interesting. Now, the persons I'm talking about, they were not conventionally, they were not at all very much trained persons. But then again, how could they develop? They could develop these things through their innovative minds. So, my dear friends, first thing is you must be innovative in your approach, and you must inculcate the sense of innovation right from the beginning, right from now. And there is nothing which you cannot do. So this is about, these things in the engineering side. But then I will tell you some of the advancements that had really taken place in India. In India, I'm not talking about, the pre-British days, because yes, there were a lot of developments like during the Gupta period, during the Maurya period, in the post-Vedic period, there had been some major developments, as you all know. But then, in the conventional sense of today's science and technology, the first important thing that came up during the British India was in 1894, when for the first time Sir J.C. Bose, he had developed an equipment or a system that, could transmit the electromagnetic wave from one place, from transmitter to the receiver. Imagine in 1894. So this is very, very interesting that in 1894, 1895, around that time, there was nothing in India. We had only gas, light on the streets. And then people were using this palanquin. There was hardly, those bullock carts, and absolutely nothing was there. But then this gentleman, Acharya Jagadish Chandra Bose, he for the first time developed a transmitter, and then he could also show how to design the detector. You in your class 12, you have studied the radio receiver. So he had developed for the first time a semiconductor based detector known as galena based detector, lead sulfide. So it's very interesting that how in a small, room of 15 by 15 feet or 12 feet by 12 feet in Presidency College in Calcutta, Acharya Jagadish Chandra Bose, he could develop, even before Marconi, the first radio which could transmit in a wireless fashion. Before that, wired communication was there, but that was one of the first in the wireless area. But I should not say that, okay, that was the first thing. But again, after Newton, a very important development that took place was in the history of science and technology was by Faraday. And you all know about these Faraday's laws of electromagnetic induction. But then the more important thing was giving it a complete scientific theory, a mathematical theory was one of the most important and challenging jobs, which was laid down by another great scientist. His name was Maxwell. So, in my opinion, after 1665, 1865, that way was a very, very important year. That means 200 years after Newton's discoveries, in 1865, for the first time, this electromagnetic waves, the concept was given by Maxwell. And when those of you who will be studying electrical engineering and electronics engineering, you have to study the Maxwell's laws of electromagnetic propagation, because electromagnetics is a very important part of electronics and electrical engineering. Maybe that even in computer science also you may study, or mechanical engineering students also may study this, because after all, this is one of the most fundamental things which governs many of the engineering disciplines. But after Maxwell could prove that, okay, optics, light is an electromagnetic wave. But then interestingly, that he had developed the theories, but interestingly, nobody had developed or nobody could really generate any electromagnetic wave in the lab when Maxwell had talked about it. So theory came much earlier, but then it was for the first time that Heinrich Hertz, he was a German physicist, a great physicist, he had for the first time developed the electromagnetic wave in Germany. But then that was in a much high, wavelength, higher wavelength, low frequency. And so Heinrich Hertz, based on in his name only that we call it as Hertz is the unit of frequency, isn't it? Hertzian wave, as we call it. So, so after Henry Hertz, there was another gentleman, Oliver Lodge. He also had developed and he had written a very good book on electromagnetics. So, Sir J.C. Bose, again, it's not that he did everything, for the first time. Every development, remember that it had a prior art. So before you develop, a lot of people they have thought about it, and a lot of people they have contributed on this area, and that's how the from Maxwell to Hertz to Oliver Lodge, and then it came to J.C. Bose, and at the same time there was another gentleman, one of the greatest physicists, and his name was Marconi. And you all know, when we were students, we all knew that who is the inventor of radio? We had to write that Marconi is the inventor of radio. But then, as a matter of fact, the whole detector, the receiver part of Marconi's radio, the concept of this Galena-based, detector, that was taken by Marconi from J.C. Bose. And this information passed in England, again in the University of Cambridge. So Cambridge is one of the universities which had generated so much of very interesting developments and very interesting things. Maybe that a time will come when people will say that, okay, Silchar is a place which has generated a lot of such very novel and interesting ideas. So it is the ideas which are very, very important in today's life. So Sir J.C. Bose, after he not only developed this wireless transmission, the communication, but he also ensured that any kind of such development, it is for the humanity, because that is what the Indians traditionally, and we had this kind of a thought that everything is for the good of the people. Everything, all the aspects of science and technology must be useful to the common people. And that's how J.C. Bose knew that he cannot scale it up. Whatever he had developed in a small laboratory model, that cannot be scaled up. While Marconi, he was an Italian physicist, and they had, Europe always had a lot of money and all. And it is because of these people that they were our rulers in a sense, the Europe. The Britain was the ruler. So they could afford to really scale it up. And that's how the engineering, it had developed much, much more earlier in Europe. All the aspects of science and technology. And it is because of the fact that we were under this rule for a long time, we possibly could not do much about it. So another person who had really at the same time developed huge kind of interest among the Indian youth, his name was Acharya P.C. Roy, Prabhulla Chandra Roy. And he was a person who had, for the first time in India, again he was contemporary to J.C. Bose, and he had talked about the need for industrialization in the British time. Today also, that kind of a need has been felt and is being felt by everybody, because everybody should not look for jobs only. A lot of people in the engineering institutions, the day they join, they look for and they take this, they inquire about the job scenario. And those days, imagine, there was practically no jobs. So PC Rai, he for the first time, he used to tell his students, and you must start your own industries. And he was a chemist and considered the father of chemistry in India. So it was because of these people that in India, remember that physics, both physical science and chemical sciences, they really grew at a fantastic pace. The whole of 20th century and before our independence, there had been lots and lots of developments through the students of J.C. Bose and P.C. Rai. And they were truly the harbingers of the fruits of modern science and technology in India. It is these people who have really brought it. Not that everything they had done, but much more importantly, they had done it through their students, through their, the large number of people whom they could motivate. And one such company which was started is known as Bengal Chemicals. Many of you might have heard about it. It's still one of the companies. Unfortunately, whatever they had started in early 20th century, now in 21st century, we are very, very eager to really banish them all. And then there are many of these companies they are becoming sick companies. Is very unfortunate, but then that's what is happening. Because of the fact that another important truth you should know, and that truth is every company or every technology in today's world, you must be relevant to the time, because competition is increasing like anything. And with this competition, since competition is increasing like anything, so we must be quite conversant with the kind of developments which are taking place elsewhere. And this is very interesting to observe that this competition is today not only amongst, for example, the first mobile phone, it was developed by Motorola. And you may be knowing that in 1974-75, Motorola had for the first time developed a mobile phone. And that mobile phone, it was weighing 1 kg, 1 kilogram in weight. And it looked like a, 1 minute, because my charger. देखिए तो হয় না। In fact, my laptop went out of charge. So, am I audible now?
Yes, sir. Yes, sir. Yes, sir.
Audible, no?
Yes, sir.
Yeah. And then, how much time I should continue? Is it okay? Should we continue? Hello. Should I continue now?
Sir, unmute your microphone, sir.
Huh? Okay. So, okay. Thank you. So what happened was, this Motorola, they had first developed that mobile phone in 1975, around that time. And then one fine morning, Motorola, the CEO, with that mobile phone, he talked to the person, one of the chief technology officer in Bell Labs. So remember that there are some companies and some of the, organizations which had given and which has developed so much for the modern science and technology that it's unbelievable. And one of them is Bell Labs. It was started, Graham Bell, you have heard about his name. In his name, the Bell Labs were founded, and then whatever you see today, most of the original things were started by two organizations. I must say that among these two, one is Bell Labs, the other one is IBM. And anything with computing and related to computers, IBM had the huge contribution, and similarly Bell Labs. So this gentleman from Motorola, he took that brick-sized cell phone, and then he talked to the Bell Labs chief technology officer to say that, hello, I am so and so, and then this is the first, I'm talking from a mobile phone, and this is the first mobile phone in the world today. So that was the beginning of mobile communication, mobile phone. But then it is because of the fact that Motorola, they took a very wrong path in getting the connected. The connectivity was not appropriately planned, and Motorola subsequently went down in the entire competition chain. Nokia, coming from a very small country in Europe, Nokia, that was very popular in the realm of this mobile phone. But then very quickly, Nokia came, and hardly for 8 years, and after that, after about a decade's time, now Nokia is not the number one company. People are using mostly Samsung. So even now, so many of the Asian countries, they are taking over. Korea is one of these. China, Korea, they are really coming up in a big way. And much of whatever we are using today are being developed in, initially it was in Japan, and now in Japan, Korea, and most importantly, China. So let's see that in India also, we have to do that. About the competitions, remember that the technology is changing very fast, and it is changing so fast that in some of the areas, for example, I was talking about the quantum computing, and in quantum computers, only in this year, that is in 2019, last year, Google, they had come up with a huge quantum computer. It's with 53 qubits, as it's called. And that, that quantum computer, that was about 10 of them they had developed. And Google said that this is the fastest and the platform which they had developed. And not only that, Google claimed that whatever this quantum computer can do, uh, it can solve some of the problems which in your conventional, even by a supercomputer, will take hundreds of years. So it's very interesting. It's so fast. Now, IBM immediately retaliated. IBM said that no, what Google says is not correct. Google had published a paper in Nature. IBM said that no, it's not correct. We also have developed the same 53 qubits, quantum computers, and then we have developed something which is much more faster than the. And then IBM's own supercomputers, they say that it's not hundreds of years. In 2 years' time, they can develop the same kind of. They can solve the same problem. So the point is, there's tremendous competition amongst these people. And you have to know that the developments which took place in the earlier years, I talked about, say, 1665, and then it took almost 200 years to have a parallel one such fantastic development by Maxwell after Newton. That was in 1865, 200 years. Again, it took, in 1905 by Albert Einstein. So that was the special theory of relativity. And then basically, all those gave the concepts of the understanding of modern day physics. So from 1865 to 1905, almost 40 years. So again, from 1905 onwards, if you just see, during the Second World War, lots and lots of developments have taken place. Those of you who will be studying computer science and engineering, see, it was during the Second World War only that lot of developments had taken place. The basic concept of computers, it came up during the war, when the war was going on. And you will know that, okay, the person who had given that whole concept of stored program concept, and his name was John von Neumann. And that continued. Today we talk about AI and machine learning and all. That was also started by one of the most important scientists of our era today, and possibly one of the most intelligent person in our times. Not our times, I may say in our times, but you may not say in your times because he is long back gone. But then his name is Alan Turing. You have to all study in your computer science course the Turing's testability, theorem. So it's interesting. You can just see how fast the concepts are changing. So again, in the field of computing, in 1942, for the first time, the neuron, now today everybody talks about neural networks, because even a child also knows about this deep learning, neural networks, etc. But then it's interesting that the first concept of how to model a neuron, that was given by McCulloch and Pitts long back, and that was in 1942 when the war was going on, 1943. So can you imagine that the war, during the Second World War, the concept how a neuron can be modeled was given by McCulloch and Pitts, and they were all mathematicians and biologists. Another important thing to my students is, please give a lot of stress in the first year curriculum when you will be going through the physics and chemistry and mathematics. Remember that these courses, it's not that, okay, you have to only get the pass marks and all, but most importantly, the whole of engineering is based on such science courses, because it is this physics and mathematics and also chemistry in many of the areas, which are just the founding subjects. And I do not know, maybe that biology in today's world, since, I mean, almost many of the applications today of engineering is coming in the biological area. And I'm so happy that Professor Bandyopadhyay has already initiated a big program in health science, in biomedical imaging and biomedical instrumentation in this institute. So I'm sure that when you will join after some time, you will get the opportunity to work in those areas as well. So for knowing more about it, maybe that a little bit of biological concepts also will be very much useful. But interestingly, time is very less, but I must tell you 2-3 things which you can take from all these. That in the earlier years, things were not much interdisciplinary. It developed in its own way. But then, as time is progressing, a lot of work is being done. So, whatever has been done till yesterday, 2019, remember that the amount of work which will be done in 2020, 2021, in 1 year's time, the total amount of development or innovation will be almost equivalent to that. Because a lot of people all across the world are working on it. Say COVID. COVID is today only, maybe that it started in November. First case was detected in November 2019. But then that's why it's known as COVID-19. But who had declared it as a pandemic in March 2020? So generally, people came to know that, okay, it's an important thing to be given stress. That means from March, April to now it is November. In these 6, 7, 8 months, you don't have any idea about how much hundreds of, enterprises, hundreds of, different organizations are working towards development of the vaccine on COVID. And for development of these vaccines, everybody, we are eagerly waiting that when the vaccine will be available. You will be surprised to know that again the vaccine itself is a concept which is an interdisciplinary concept. Nothing today is only biological or medical and all. Because without the help of engineers, nothing can be done. And one of the most important developments is in the area of nanotechnology. For example, nanotechnology is coming in a big way in not only just the sensing of COVID, because today the time is coming that COVID is not the end of it. Today we have got COVID-19, and this kind of a pandemic will continue. I think you will have a very tough time, those of you who are all youngs, and you have to live with it. So what science and technology demand is you must have a scanner. A time will come when a scanner will be available, and the scanner will be able to detect whether there is any virus around you or not. How beautiful. How can it be done? Again, you may have to use the nanotechnology. That means the technology that we have been doing in the macro level. Then it came to micro level. Then now it's in the nanometric level. Nanotechnology means, suppose at least say whatever you are designing and developing, it must be of the order of, say, hundreds of nanometers. Usually, at least in one dimension, it should be less than 100 nanometer, but generally, 300, 400, 500, 700 nanometer is fine. Today, for example, this COVID, this kind of virus, its dimension is only 65 to about, say, 120 nanometer maximum. And the kind of masks that all of us, all over the country, we are using is cloth masks. It cannot really check the COVID virus. How can it check? Because, its porosity is so high, it may be in the order of several hundreds of microns. And the virus is so tiny, so small, that it can always enter through that. So what has to be done? So you have to do the detection and then immediate annihilation of the bacteria or virus. And that can be possible again through nanometric sized sensor. So it's nanosensors for COVID sensing. So in my current institute, we are working towards development of that. It's a private institution, small way we have started. But then tomorrow's COVID must be sensed. Not only that, you sense COVID, then what happens? So you have to kill, you have to annihilate, you have to destroy that virus. And for that, you have to take care of such nanometric sized material which are antiviral. So antiviral drugs will be embedded on a nanometric sheet. So that's very interesting. For example, if you take a sheet of, say, maybe that 6-inch by 6-inch, or maybe 1 foot by 1 foot, and then you embed those antiviral drugs on that sheet. Now, that sheet may be a nanometric sheet. That means there are a large number of such sheets which are available, these nanomaterials which are available. If you can put, say, even gold or silver nanoparticle on it, they themselves are very much, they will repel the virus. So very interesting. And you put it and you make it in the form of a scanner. And with that scanner, you can find out that how many such particles have been attracted or have been computed. You can compute it. So today's microcontrollers, those of you who will be working in electronics and computer science and electrical and these kind of things, you will be using, these microcontrollers, which are very important. And then these microcontrollers can be useful in telling you that, okay, so much of virus has been detected out here. So science and technology is taking a fantastic kind of in leaps and bounds. It's moving, and in different dimensions, in different directions. Not that everybody is thinking the solution in the same line. There are as many lines of solution as there are, problems. So there are plenty of problems. Each problem, you have to identify the problem and try to find a solution using a multidisciplinary approach. How can you be multidisciplinary? You have to have a very strong base in basic science, in physics, in mathematics. And that's how, now people are saying that, okay, this machine intelligence, which is so important, machine intelligence will be used now. It is now being used almost in all the areas of human endeavor. Even in COVID, in understanding the COVID virus itself is a big problem. It has got a, genetic material, and to analyze that genetic material, which is a very small gene, human genome, it is much, much larger. But a biological bacterial genome or a viral genome is much smaller. COVID genome is hardly, it's nothing compared to the human genome. Few kilo kbs. So the point is such a small genome, but it has got a lot of tricks in it. Because remember that in nature, when you are trying to, win over nature, over these kind of viral species or bacterial species, they are also getting adapted. So adaptability is the most important thing. And when they are becoming more and more smart, our technology also has to be more and more smart. So the difference of the technologies, the technological developments which have been taking place ever since the first industrial revolution is that as time is progressing, we are going to observe much more faster ways of multidisciplinary approaches. And the most important thing is everything must be intelligent and must be smart. So it is yesterday's technology. If it is not that much smart, tomorrow's technology must be a smart technology. Whether it is in civil engineering department, a lot of people, now there are advertisements that when you are making these cements, then make them antiviral, antibacterial. Corrosion must be very small in case of a lot of such, your doors, windows when you are developing. In civil engineering, there's so much of advanced technology which may be used because many of you must have been getting admitted to civil engineering. So it's so important and so interesting that, for example, if you have got you may have to do the retrofitting. For example, in a poor man's house, you find that somewhere there is a problem, and I mean on the surface, the cement surface, it's getting eaten up. Not in the cement, even otherwise. So what do? A very new kind of cement is being now proposed, which will be antibacterial and which can grow and which can really fix in a much better way. So you can do the retrofitting on the old houses for the poor people. Whatever we do today, it must also be very low cost, and it must be very targeted, and it must be very high quality. It must be very highly sensitive, and there are so many such interesting things. So the journey will continue, and you will have to give the leadership, my dear students. So you are the leaders of tomorrow with the help of your teachers. So you learn newer things, and now that internet is there with you, and yes, environment somebody had talked about, which is the most important thing, and everything should be environment friendly. One of my friends has written here, and that's so important. It must be environment friendly because otherwise the future is going to be very, and it's already very bleak. And since environment is one of the most of whatever we do, whether it is in basic engineering, in core engineering, or in computing engineering, in electrical sciences, everywhere you have to think about the environment friendliness of the new technology. And with that, even the electrical technologists you are using, or you may be, and you may be more busy in understanding how to develop the carbon based energy generation using coal based or petroleum based. But then tomorrow's technology will need more of renewable energy, which is much more friendly to the environment. So the whole kind of this on every subject one can really talk for hours, and there have been so much of developments. But the core thing out of all these is we are becoming more smart, we are becoming more interdisciplinary, and for doing that we must be true to our purpose. And my dear friends, in your lifetime, you will find so many technological changes. We have seen huge number. When we were students, we had to study bulb devices in electronics. And then we saw through so many generations, transistor came, then field effect transistor, then IC came, then large scale integrated circuits came, microprocessors came, and then advanced microprocessors came, microcontrollers came, from normal sys computers to RISC computers came, and then today, supercomputers, and then we are at the fag end of our lifetime. We are going through the quantum computers, which is such an important and such a fantastic development of mankind. So you will also see lots and lots of such developments. Please give more stress in a focused way. And here is an institute which will give you truly the environment to learn, and learn. Think think and think, and then try to develop lots of things with an inquisitive and innovative mind. So we who are your teachers, your seniors, we have got all the blessings to you. Thank you very much and very best wishes for a fantastic journey ahead for the next 4 years for all of you. Thank you very much.
Yeah, thank you, Professor Rai. It was an exciting journey starting from 1665 to 2020, and how the inventions basically came into being. When mankind was faced with challenges, I think at the same time, the solutions, the most of the innovative solutions came during that period. So challenge is the key that raises the problem, and solutions come from innovators, and innovators for the future generations, the set of students that we see today. We do believe that in the future we will be making up stories, innovation stories from students like you. Thank you, sir. Now, Arif. So,
Yes, sir. Thank you, sir. We all are amazed to see and experience Padma Shri Professor Ajoy Kumar Ray's addresses. Every time we listen to him, we are quite amazed to see how a person can hold such a huge resource of information about evolution of technology. And let me tell on this occasion that he not only holds this information about science and technology, he's also having a deep interest in the cultural traditional values, cultural history, evolution of not only Indian cultural history, but also international history as well. We'll have time in our hand to listen to him in future. And with this, with the permission from our director, sir, we are concluding this first motivational talk series by none other than our very own beloved, respected veteran Padma Shri Professor Ajoy Kumar Ray. You are just like an umbrella to us, sir, and your motivational talk brings confidence not only to our students, but also to all the faculty members of these institutions. We are deeply, deeply blessed by your graces, sir. And we all believe that an umbrella can't stop the rain, but it can make us stand in the rain. And the confidence you bring in us is actually brings a success. It gives us the power to face any challenge in life. Thank you very much, sir.
Thank you. And,
Thank you, sir.
And all the
Yes,
best
sir.
to all of you. Yeah.
Thank you, sir. So with this, we'll be concluding this motivational talk series. We will be meeting like this with some other motivational talk by some other experts in this way, and we'll be motivated towards reaching an excellent and happy life ahead. Thank you very much. Good evening to everyone.
Thank you, sir.
Thank you.
Thank you, sir.
thank you.
Thank you.
So we can close the meeting now, sir.
Yes,
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 sir.
please.
Okay.